So basics of structural dynamics. So before discussing about what is meant by how exactly a structure behaves under a dynamic force, so we will first discuss in detail about the difference between static force and dynamic force. Static force, a force does not vary with respect to time, whereas here dynamic force varies with respect to time. So what are the examples for a static and dynamic force? Example: self-weight or a dead load offered by a material which remains constant with respect to time, whereas dynamic force, example, a wind load. Say just there is a tree. Okay, there is a tree, and there is a tree here. And there is a wind acting on the tree, right? The wind is blowing on this tree. So wind is blowing on this tree, and due to this wind, the tree experiences a forward and backward motion, which we normally call it as an oscillation or vibration, right? So next, we will see about response. Next we will see the response exhibited by a structure to static and dynamic force. Say just you take a portal frame in two-dimensional. So let us say that this portal frame is subjected to a force of say 20 kilonewton. So 20 kilonewton means it is not going to vary with respect to time. So that is what it means. So this force is actually a static force. So due to this, the displacement will be the displacement experienced by the structure. The displacement experienced by the structure when compared to the original configuration is something like this. Okay. So So this can be erased. Okay, the displacement cost will be, can be simply explained by, okay, so this is the original configuration, and this is how the structure would have experienced. So this is called the sway or displacement. This is called a sway or lateral displacement experienced by the structure. So when the force is static, the force is static, the displacement produced, or the force is static, the displacement produced will be of static nature. That means it remains constant with respect to time. Remains constant with respect to time. Okay, so next, we'll see response to dynamic force. Dynamic force response. This is nothing but a structural response. Just consider the same portal frame subjected to a force, right? It is going to vary with respect to time. Say for example, same 20 kilonewton with respect to time. So what does it mean? It means that you can plot the force with respect to time. So here the variation of force with respect to time, you can plot it by this way. Here, so this is in terms of say kilonewton. So this is a maximum magnitude of force. So where here we have represented this unit of this force is 20 kilonewton, but it varies with respect to time, right? So this is nothing but 20 kilonewton. So it varies with respect to time. At time t is equal to 0, it remains at rest. It remains 0, and at one point of time it reaches the maximum value, and again it comes back to 0, and again it reaches the same 20 kilonewton in the other direction. The direction changes. So I said in my previous lecture, that is a classical example for a structural for a dynamic force is wind load acting on a tree. So you could see that the wind acting on a tree will have a constant shift in the magnitude as well as direction. It will not be acting in the same direction. Also, it will not be acting on a with the same magnitude, right? So this is what this diagram represents. Okay, so this is nothing but this is the force. This is what you can call it as the force F of t is equal to you can call it as 20 sine omega t. So this expression can be represented as 20 sine omega t, where 20 represents the magnitude of force in kilonewton. So sine omega t, what it represents? So sine omega t, what it represents? So we would have studied in the in our elementary physics. You can the pendulum, okay, a pendulum. If you are taking the pendulum to to an extreme point. Extreme point means if you just disturb the bob by taking it to some distance and then leaving it off, this bob will come to its original position. This is original position. Then can shift to can just accelerate to the another maximum another extreme end. Okay, so this will proceed to this the extreme point. So this motion of pendulum can be explained in terms of a what is called simple harmonic motion. But here, this case, it should be different. So how it should be? It will not be a sine wave. It will be something like a cosine wave. How means, say this is the graph, and so this is how the motion of a pendulum. This is the exactly it represents. So this is what initially the bob was taken. Initially the bob was disturbed, or initially the bob was displaced. So only you can create an oscillation, and this point represents the original position. This point represents the original position. The bob comes to its original position, right? And then the bob goes to a negative extreme. That is what this extreme. This says the extreme. So likewise, the motion of the pendulum is explained by means of a simple harmonic motion. In a similar way, a time varying force can be graphically represented. Okay, here in this case, this curve is a sine curve, whereas this is a cosine curve. Okay, so now, if this acts on a structure, right? Okay, if this say the same portal frame and subjected to what is called a time varying force 20 sine omega t. So how exactly the displacement will be produced? So what will happen due to this force? The structure may be experiencing it will move to one extreme from rest position. Say this is the rest position. This is the rest position. Rest position, and then so this is the it is not clear, right? It is not clear. It is not clear. So we'll once again draw. So initially the structure is at rest position. This is the rest. Again the structure experiences it moves to the one extreme, moves to one extreme, and then comes back to normal rest position, then moves to the other extreme, moves to other extreme. So this you can draw it, this displacement. So displacement you can draw it with respect to time. So how it will be, initially it was at rest and then it moves to its, here there is no space, that's why I have drawn like this. So this is the maximum displacement. So this is what maximum displacement. So the structure was originally here. So this is the maximum displacement. This is the maximum displacement. So this is the rest. A rest, extreme, then rest, this thing, and then moves to the next extreme. This is the other extreme. Other extreme. So the maximum displacement. So this can be, if you just call displacement, if you just call displacement as in terms of x, this diagram could be, call it as x of t is equal to x naught sine omega t, right? So that means, so displacement caused by force f of t is equal to 20 sine omega t will be equal to x of t of x naught sine omega t. X naught represents the maximum displacement experienced by the structure, experienced by the frame, okay. So simply we'll summarize everything what we have seen today is that a static force, right? Say a static force, F static, okay, F static causes static displacement, whereas a dynamic force, whereas F of t, dynamic force, causes dynamic displacement, okay, that is, or you can call it as time varying displacement, okay. Thank you.